Hi, I'm Miss Hall, and this is Lesson 72, Trigonometric Functions of Any Angle. You can generalize the right triangle definitions of trigonometric functions so that they apply to any angle in standard position. So let theta be an angle in standard position, and let x, y be the point where the terminal side of theta intersects the circle, x squared plus y squared equals r squared. The 6 trigonometric functions of theta are defined as shown below. These functions are sometimes called circular functions. Okay, so you'll see we have theta, then we have its terminal side, and we find the point x, y, where the terminal side intersects x squared plus y squared equals r squared. And then we make this right triangle. The radius is r. Then we have x and y. And this is our reference angle that we'll be going from. And so we can label the three sides as the hypotenuse, the opposite, and the adjacent. So just to do a few, you remember that sine is opposite over hypotenuse. And if you look at what I labeled the opposite side, that is the y value. The hypotenuse side is the r value. So that's where they get this ratio, y over r. I would not memorize the ratios in this core concept diagram. Rather, I would memorize, I'm going to practice drawing this diagram and labeling the sides. Example 1. Let -4, 3 be a point on the terminal side of angle theta in standard position. Evaluate the 6 trigonometric functions of theta. So here I go drawing the diagram. We have our circle. I'm going to say right around here is the point -4, 3. So let me draw my angle. Here is the terminal side. And this is theta. And now I'm going to create the right triangle. Here's the right angle, and I've marked my reference angle. And now let me label the sides. So we have the x value of -4. We have the y value of 3, and now we need the radius. Well, I can see this is a 3, 4, 5 triangle, right triangle. So I know that's 5. If you didn't know that was 5, you could use the Pythagorean theorem, a squared plus b squared equals c squared, to find the missing side c. Let me label the sides. We have the hypotenuse, the opposite, and the adjacent. Remember, opposite is across from the reference angle, adjacent is next to. And now I can write out my 6 trigonometric functions. Sine of theta, cosine of theta, tangent of theta. And then the reciprocal functions, we have cosecant of theta, secant of theta, cotangent of theta. Okay, and then I can write SOHCAHTOA, some old horse came a-hopping through our alley. So sine is opposite, 3 over hypotenuse, 5. Cosine is adjacent, -4 over hypotenuse, 5. And tangent is opposite, 3 over adjacent, -4. And typically in a fraction, just put the negative sign out. Now, the functions underneath are just reciprocals of the one above. So cosecant is 5/3. Secant is -5/4. Right, we just put the negative sign. And cotangent is -4/3. The unit circle. The circle x squared plus y squared equals 1, which has a center 0, 0, and a radius 1, is called the unit circle. The values of sine and cosine are simply the x and y coordinates, respectively, of the point where the terminal side of theta intersects the circle. Right? So it's helpful for me to fill in this diagram a little bit more. Remember, this is x, this is y, this is the r value, which is now 1. In the unit circle, the radius is 1. I have my right angle and my reference angle, and I can label the sides as the hypotenuse of this right triangle, the side opposite my reference angle, the side adjacent. Okay, so let's go through. They said the sine of theta, sine is always right opposite over hypotenuse. Opposite is y, hypotenuse is r. But r in a unit circle is always 1, so this is y over 1 equals y. So the sine theta is simply y. You can see the same thing with the cosine. Cosine is adjacent over hypotenuse. Adjacent side is x, hypotenuse side is r. In a unit circle, r is 1. X divided by 1 is x. So the cosine of theta is x. And you are, through lots of practice, going to need to memorize that in the unit circle, each point can be represented as cosine theta, comma, sine theta. Right? Because cosine theta is x and sine theta is y. Example 2. Use the unit circle to evaluate the 6 trigonometric functions of theta equals 270 degrees. Let me draw a unit circle. And label my degrees. That's 0, 90, 180, 270 degrees. And so 270 degrees is my terminal side. Like this. Can't really draw a right angle here, so I'm going to have to use what I learned before, just up above on this paper, is that for any point, and this point is 0, negative 1, we can rewrite it as cosine of theta, comma, sine of theta. Which means, let me write out the 6 trigonometric functions. We have sine of 270 degrees, cosine of 270 degrees, tangent of 270 degrees, and we have cosecant of 270 degrees, secant of 270 degrees, cotangent of 270 degrees. Okay, so sine is the y value, so it's negative 1. Cosine is the x value, which is 0, and tangent, you'll need to remember this ratio, that the tangent of theta is equal to the sine of theta over cosine of theta. Should be a ratio from geometry. The way I remember this is to get a tan, you need more sun than clouds. So S goes above C. Which, let's see, so the tangent is going to be the sine. So it's going to be negative 1 over the cosine, 0. You cannot divide by 0, so this function is undefined. Now I need to take the reciprocal of all the ratios in the top. It's going to help me to rewrite them as fractions. So let me say that this can be written as negative 1 over 1, which will be 1 over negative 1, which is simply negative 1. Cosine is 0 over 1, and if I flip that, I get 1 over 0. You cannot divide by 0, so this is undefined. And then cotangent is going to be 0 over negative 1, which is 0. So let me highlight the correct answers. And there you go. Those are the 6 trigonometric functions of 270 degrees.